The subject of the study is work systems, and the purpose is to demonstrate how systems such as Lean, Six Sigma, motion studies, etc. can improve efficiency of production systems. Our initial process would not allow us to meet the current demand. However, after applying our work studies, we can now reach and even surpass our goals. Our system is made up of the workers, Cody, Daniel, and myself, the different workstations where we build the pins, and the conveyor belt on which we move our finished product throughout the warehouse. Controllable parameters include factors such as the number of workers, the setup of the work systems, and the speed of the conveyor belt. The uncontrollable parameters would be things like the bad or malfunctioning pin parts and machine breakdown. The main undesirable impact of problem would be a delay in delivery time, which could in turn make us lose clients. The scope is simply the demand for the year, which is 720,000 pins, and the limitations would be the manpower and the number of hours available to complete each order.
Okay. Go ahead and talk about it.
So our standard pin assembly procedures. First we're going to be taking the pocket clip in the upper barrel and press the clip into the non-threaded end of the upper barrel. Holding the upper barrel with the clip on the bottom, place the appropriate coating plunger into the upper barrel with the rounded end installed first. Then next, continue holding the upper barrel with your left hand and then place the cam with the small end first into the upper barrel. Then you're going to take the ink cartridge and put it into the upper barrel with the right end pointing upwards. Then you'll grab a spring, put the spring on top of the right end, and then finally you'll take the lower part of the barrel and assemble the two pieces, and then check that the pin clicks and writes properly. We changed our procedure a little bit, that way you can do everything while holding with the left hand and then do each procedure with the right hand, so you don't have to waste time setting things down and picking them back up.
Works.
That work.
Okay. And here is our procedures for the pin assembly that he just went over, and layout of our work area, part numbers, the bins. Okay, this is our floor plan here. It printed with the margins a little bit off, so it's kind of hard to tell some of the where the arrows are going. Okay, so we start out, we have our injection molding machines here. They're supposed to be up here, but they feed the products from there will go to these two trim lines here. Once the parts are trimmed and cleaned up, they will go over here to the finished parts. The ink drums will feed the ink cartridge machines. They will fill the ink cartridges for us, and then those will be shipped over to the finished parts. Right here is the spring winder producing the springs, and when that is done making the springs, they move over to the finished parts. Once we have all the finished parts that we need, then the finished parts will be distributed to the red station, the blue station, and the black station to produce the red, blue, and black pins. From there, those parts, once completed, will be sent over to shipping and receiving to be shipped to our customers. This right here is an operations chart, which pretty much just illustrates what Jacob went over in the procedures with the order of the way we're producing the pins and how we assemble them. The process chart is basically the same thing, just lists the time per second that it takes to do each step in the process, which we're currently at about 25 seconds per pin. Here is our left hand and right hand chart, showing what each hand is doing throughout the operation. As you see, our left hand tends to just be holding the barrel, so it's not being really utilized in a good way, while the right hand is doing most of the work.
And here's just a little close-up of each chart.
buying cards. Alright, here's our Kanban cards. As you can see, zoom in here on one of them. The blue one here, we have our part number, which PL stands for the plunger, 2014 for the year, 04 for the month, 131-1 is just the actual part number for a blue plunger. We got our quantity and what station they belong to. So as you see here for the black one, we have the same information for quantity and what station it goes to, except for on the part number it ends with a 132-2, which is for black. And for the red, everything else is the same. The quantity is different because we don't make as many red pens. And the part number is 133-3 for red. All the other corresponding parts will have the same dash number at the end of them. So if we grab one for the clips, see these clips will also have the -2 for black, letting it know that it requires a black clip, not a blue or red. Go.
I need blue clips over here on station 2.
We were given a table of demand per month for a year of how many pens our customer wanted. That equated out to roughly 720,000 pens. We were asked, will our system be able to meet that demand? What I did is I took our standard time of 23.8 seconds per pen, took the inverse of it, which gave roughly 0.042 pens per second, and that allowed me to calculate how many pens we would have in a year, or at least per month. But what I did is I took our standard time of 0.042 pens per second, multiplied that by 60 seconds in a minute, multiplied that by 60 minutes in an hour, multiplied that by 24 hours in a day, and I multiplied that by however many working days we had in that specific month. For example, January has 21 working days, July has 22, November has 18, and October has 23. I mean, the majority of them all have the same amount of working days, which is 21. That was our average. But you can find the chart of these numbers in the file that we turn in. But I'll explain one. For example, in the month of January, we were expected to have, our demand was 60,000 pens. And January has 21 working days. So what I did is I took 0.042 pens per second, multiplied that by, as I said before, 60 seconds in 1 minute, multiply that by 60 minutes in 1 hour, multiply that by 24 hours in 1 day, multiply that by 21 days in 1 month. And that gave me 76,235.3 pens for that month, or a net gain of over 16,000 pens, which, I mean, it's a good start. But further along, I mean, we didn't have 60,000 demand for every month. For example, in August, we had 75,000 pens demanded, and I can happily say we produced 76,235.3 pens, theoretically, of course. No month were we ever behind in demand. And at the end of it all, we were expected to produce 720,000 pens. We produced approximately 911,000. We were capable of producing at least 911,000 pens.
Okay, this is our original floor plan. One way that we could feel like we could possibly improve this is if we could move the red station over here in line with the blue and the black station. Instead of having a circular belt moving around, if we just had a continuous straight belt, so the finished parts would come in here you would put your finished parts on the belt to go to which station they need to go to, as that station needs more parts, using the combine cards. Once that station gets their parts, they make their pins, put them on the assembly line. A person here would collect those finished containers as the red, blue, and black stations completed what they needed to produce, and then they would go on out to shipping. This would prevent the conveyor belt going around and have everything more linear. On the process chart, if we had a jig to put the upper barrel with the pocket clip, once the pocket clip's attached to the upper barrel, if we had a jig to put that in that would hold the upper barrel straight up and down, then we would be able to assemble the parts using both hands, which would cut down on the amount of time it took to make a pin, and we could save approximately 3 seconds by using both hands. Our right hand, left hand chart kind of shows us what both hands would be doing. As you see in this chart, how much all this black is idle time for our left hand, whereas if we was able to have a jig that would hold it up, we could utilize more time with our left hand and cut down on the amount of time it takes to produce each pin.
And again, just another close-up of the improvements.
In conclusion, through our systems such as Lean, Six Sigma, and time studies, one can increase efficiency of a process, which can lead to increased capacity as well. One recommendation would be to have a linear conveyor belt instead of the circular one, so that after a product is finished, it goes straight to shipment and doesn't go around the circuit again if it's missed or anything like that. Although work systems increase efficiency, it doesn't just stop there. Work studies can only do so much. One must combine work systems with new technologies in order to reach the highest level of efficiency and capacity.